Alright, what's up everyone? Manny B here. It's late, it's Friday night, it's past 9 o'clock, and I'm pretty tired. But I'm also pretty pumped because earlier this week I hit the 100 subscriber mark on my YouTube channel, which is kind of cool because I've really just been YouTubing for a couple of weeks now and only have a couple of videos. But you guys seem to enjoy the videos and they seem to be helpful. So last video, we trained a model on a fraud detection use case. Now we're gonna take that model and set up an API so that someone through a web browser can ping it and get a prediction off of that model and read it into an application. Why this is cool is because a data scientist's job doesn't end with just a trained model. You have to get the outputs of that model to the end consumers. Sometimes that's in an application, sometimes that's in a notebook, sometimes that's in a report, but one of the coolest way to do it is via an API, so that someone can just send you the variables for a particular observation. It scores on the model and sends out the results to that particular requester. So that's APIs, and we're gonna talk about them now. If you're new here, please subscribe. Check the subscribe button and the notification button so that you get reminded whenever we put out a new video. So now on to the tutorial. All right, everyone, let's jump in. Okay, so I'm just gonna cycle through the various applications that we're going to be using in this tutorial. So we have our Anaconda prompt, and we have our web browser where we're going to do a couple of things. One, we're going to have a Jupyter Lab notebook so that we can walk through the machine learning model. And we're also going to use it to do some basic testing of our API. We're also going to be using Postman, which is a tool that allows you to hit an API endpoint. That's this little thing here, this address, to either post some data or to get a response. So that's Postman. Make sure you have that installed as well. But let's start off here in Anaconda prompt. So because we need 2 kernels of Python running, we're going to need to have another prompt to run that. So let's do start command.exe. That's going to bring up this bad boy. Okay, and then we're in the same directory, and we're going to use this to bring up our Jupyter Lab notebook, and this is going to be used to bring up our Flask API. So let's see what we have here. Let's actually just clear this out and see what we have here. Okay, cool. So we're gonna want our API, our Flask API Python file here. But first, let's step through the data science model that we put together. Now, this is the model that we ran through in a previous video. It's cleaned up a little bit because you don't have any of the EDA stuff, the discovery stuff. It's really just the basics in terms of the transformation and the model training, which is all you really care about. So you have your R&D phase of your process where you're kind of exploring the data, you want to chart stuff, and then this is the delivery part where you just really care about the model, taking inputs and serving up predictions. So this is a slimmed down version of what we did last time, but if you want to check that out, I'll have a link to that video in the description below. So all right, so first things first, let's just close this out here and we'll walk through this. Again, we're importing our necessary libraries, we're bringing in our data, we're merging it together. We're creating a train test split so that we can train and then test on a new data set. We are subsetting our columns here, doing that here from the full data, where we are dealing with our categorical and variables by at least one variable by creating a dummy variable of this particular column, and then splitting that into our X data set and our Y portion, and just cleaning up the data a little bit here. All right, so data is finished at this point, and here is where we're pulling in libraries to do some of the modeling. And this is new. This you wouldn't have seen this in the previous video, because this is the library that we're going to use to save the model to our disk or to our local machine as a file. It's going to be saved as a pickle object. And that's going to be important because our Python script, the API script, is going to be able to pick that model up and use it to score the request from the API. Okay, so this is new as well. This was not in the other video. This is setting the I guess the random generator seed to a certain level so that you get the same type of output from the modeling in a consistent fashion. If you don't do this, certain things might change as you're running a particular algorithm, and you may get slightly different outputs and predictions. So this is just best practice to help with reproducibility. Okay, so this is all fairly should all look familiar. Okay, just kind of scoring here, just checking it out. I guess you don't need this, so cut that out. Generating our predictions. This confusion matrix. Actually, we don't need this either. And this is new too. This is something that I use to get a sense of where my model was predicting an actual fraud in the data. So what this is saying is, create a data frame from our Y test array, and also the predicted results. Excuse me, the predictions from the model. And then here we're subsetting for instances where we have a predicted fraud and an actual true fraud. And then here's a table of that. And then what we can do is we can grab one of these observations, and then we can pull that from our data set to pass it through to our API and see if we get a similar result. So if this is telling me that this row here, 9616 is an actual fraud, then I should see this when I test my API. So just a way to get some observations to test out. So if I run this, I should get a 1 predicted, which I would do here. Actually, let's just run it here so make sure that everything's running okay. So let's do that, all that good stuff. And then I think we can stop there, and then okay, so we'll wait for that to run. Will be about 10 seconds or so. Okay, let's just wait for that before we move on so I don't lose my train of thought. Okay. I'll have to edit this in the video. I may actually not have time to fully edit this, so this is probably going to stay in. I don't know why it's taking so long. Let's move up. Let's see here. Is it making any progress? Okay, yeah, it is. The merge sometimes takes a little bit longer. Why is this taking so long? Oh, okay. Oh, okay. It's blazing through this, boom, pop, 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 and it's gonna get stuck at the model training process here for like 5 seconds. 5, 4. Oh, bam, beat me to it. Okay, cool. And then, all right, so now this is a 0. So that's why I guess I hadn't set the seed in the previous version. So let's test this out, and this should give me a 1. Bam. Okay, cool. So this is a 1. So this is the prediction here is a fraud. Okay, so this is a fraud that we're predicting. So same thing here. Okay, bam. Okay, so the next thing that we want to do is we want to take that observation from our X data set and create a JSON. So this is the JSON data that someone would send to our model wherever it's being served up via API, and it has to be sent via JSON because that's just the standard protocol and language that's used for these sorts of things. And so if our model were to receive this JSON, it should return a prediction of this transaction being a fraud. So we're going to use this to test that out. Okay, last thing that we're going to do here is we're going to import our this library to save the model as a pickle object. So this actually, let's see here. Actually, no, this is, no, yep. Okay, yep, you need this, and then this is just loading the model and generating predictions to see if it works. But I don't think we need to do that, so let's cut that out. And let's just save that. This is the part you need right here. This is going to be saving your model as a pickle object, and it saves it to the local directory so that we can pick it up and have our Flask app score on it. All right, so that's the training part. Now let's set up our API. Okay, so what we're gonna do is we're going to bring up that the Flask code of this now. By the way, this is in the Git repo. I'll provide a link to that Git repo in the description, so check it out. You'll have all this code that you can look through. Okay, so here what we're doing is we're importing our necessary libraries to run our application. This is a key here. You want to make sure you have this, you set this to true, because it'll allow you to change this script and have that reflected in real time as you're testing the API. If you don't have this, then if you make any change here and you save it, just kind of it just kind of bogs down, which is not terrible, but it's just, as you're building, you want debug to be true. It's just kind of helpful. Okay, and then here is just going to be our standard home route, and just going to return this. So we'll see that in action, and this will be returning HTML. So this is actually not an API call. If you'll probably something funky if you try to call this via API. Now here is where it gets interesting. So this is where it's actually calling our API, and this is just a standard GET request. That means it's just going to me as a requester, or the application that's requesting, is just going to get this data. So it's not really doing anything responsive. It's just sending this this data here, and it's going to return it in JSON. So that's what we're doing right here. And then the interesting part, this is where it gets interesting, is actually making predictions on new data via API. So this is the route that's doing that. So when we call this API endpoint, we're going to post the data that we're going to receive from the requester, and it's going to take it as a vector here, after converting it to a data frame, we're going to load the model that we saved earlier, and the model file name should be up here. So here's our model pickle. This is what we saved in the Jupyter Lab notebook. It's going to convert that. It's actually going to run that vector, and it's going to run it through the predict function in that model, and we're going to grab the first item in that output. We're going to create a string from that, and we're going to pass that to our y-hat variable. And then as a bonus, so this is going to be like our 1, 0 is 1 is a fraud, 0 is not a fraud. And then as a bonus, we're also going to send the prediction probability of that fraud. So when you're doing a binary classification problem, yeah, you get 1, 0, but the threshold at which point you classify as a 1 can vary. So you might say that if the model predicts anything greater than 50%, then classify it as a 1. But you can change that. But sometimes it's 55% versus 95%. So as a consumer of this model, you might want to know if the model is saying, hey, this is a 95% probability of fraud versus a 51% probability fraud. In both instances, you're going to get a 1. Yeah, this is a fraud, but for 95% probability, I may be more willing to accept that. If it's like 51%, it's on the borderline. If it's $2, $3, maybe I just let it pass and not risk the inconvenience to my customer. So that's why I think it might be important to also send the prediction probability as well. Okay, so we're doing that, passing that to this function here, and then we're grabbing that probability percentage, and then we're rounding it here so that it's not too wonky, and then we're just pairing those two together, and then passing that to JSONify to send it back in JSON form. And this is important too. Don't forget this at the end of your Flask app.run. If you don't have that there, your Flask app is not going to run. Okay, cool. So now let's do that. Let's run our Flask app here. And because we have this command here at the top, all we have to do is really just run the Python script. So we can just say Python. What did I call this again? Flask. Yep. Boom. Okay. So that should kick up. All right. So the web browser part of this should be running here. So let's go to our Chromebook here. Ooh, our bloggers. We're doing Python now. R I still love, but this is Python. It's a Python stage right now. I'll go back to R. I love R. Tidyverse is great. Just Tidyverse just pulls you in. Tidyverse and RStudio are like the greatest things ever. So I don't think I'll ever get away from R because of that. And ggplot. Well, I guess ggplot's in the Tidyverse, but so good. Anyhow, all right, cool. So this is what we saw earlier today. Manny B. It must have been late when I was writing this. Look at this. Oh my gosh. Manny B in the house, fraud detection. Okay, cool. So let's see. Let's go back and let's change this. And this is where this is in the route home here. So let's change this to let's just say Manny B not in the house, but Manny B is oftentimes in the house. And then control save, and then if you see here, it just restarts it, and then we can cycle back over here and then refresh this, and then it changes that. So that's pretty cool. Okay, that's just testing the web browser part of this. But And APIs are cool, are very cool. All right, so now let's test the API part of this. So what we want to do is we want to go over to our Postman, and we're going to do two things. We're going to test the generic GET request endpoint, and that's just going to, we don't need to really do anything there. We just have to hit that endpoint, and it's going to dump the data back to us. And if you recall previously here, that's just here, and then it's just gonna send this here. So let's go to Postman, and then here we're grabbing this, and we're just attaching that to the end of our logo port here. Okay, so you can see here and attach this. Okay, pretty straightforward. So then we use that, send, and bam, here we go. Here's what the requester would get. Description man to be tested. API, so let's go back here. Let's make sure we're getting this. I'll call this user description, saying, hey, testing out APIs. So cool. I heart APIs. I heart APIs. Okay, can you tell that it's late here? It's late. Okay, so sorry about that, guys. Get a little wonky. Okay, so now let's go back to our Postman and let's send that again. Boom. Okay, so now this is different as well. So that's pretty cool. All right, so now let's test what we really care about, which is a prediction on the model. So for that, we have a separate endpoint. And if we go back to our Flask app, you're going to see that right here. Okay, so it's API predict, and we already talked about what this is doing. Now, to test this, you're going to have to go, now you actually have to send something with that request. It's not enough just to send, just to hit the API, you have to send something. So you'll go over here to body, you'll click this, and this is the previous transaction that I had. And if you remember, this gave me back a non-fraud prediction. So let's just run that again and see if that's the case. Oh, and it's a 1. Interesting. So this must be a different one than I had. But still, let's test this out. And let's see here. Let's go back to Jupyter Notebook. And let's do this. Okay, let's see what we get here. LR predict prob. All right, tab gives you the autocomplete. So let's grab this observation and let's see what we get here. Okay, so what this is telling you is it's saying this is the probability of a non-fraud event. This is a probability of a fraud event. So this is a 1, so it's predicting that it is a fraud, and it's 87% likelihood that it's a fraud according to this logistic regression model. Okay, so now let's take that. Okay, let's create a JSON item off of that. Okay, by doing that just to test it. So we're just taking that data, we're making a JSON. Now let's go back to our Postman. Okay, let's delete this. Okay, so now I'm expecting a 1 here and a 87% probability roughly. So let's see what we get. Whoa. Okay. This is cool. Why is this happening? Did I must have saved a different model as the pickle object. Okay, let's go back. So again, I ran the script I think previously to set in the seed. So I wonder if it's got a slightly different logistic regression model that it's calling something to say previously. So let's actually test that. I guess I can check when the last model was saved, but why don't I just go back here and just resave the pickle object? Because I don't think I did that. I don't think I did that here. Okay, so let's do that. Okay, so we should have saved that. And let's go back. I wonder if it picks up the new pickle model. See, this is kind of cool because this is how I like to learn things. So I like to try to make predictions in terms of what I think would happen and confirm whether or not that's the case. And it helps just confirm that I understand what's going on underneath the hood, right? So there's one of two things that can happen. Either and I'll sort of try different things and see what works. Anyhow, so I think there's one of two things that can happen. Either the Flask app has already picked up the new pickle model and will rerun that model, so I will get the expected percentage that I have in the notebook, or it may be that the Flask application, the script, picks up the pickle model object when you initially run it, and that's what it runs. I mean, that'd be the more efficient way to do it, because you probably don't want to reload that model every time you call the API. So let's see. If that's the case, then I would expect this not to change. Interesting. It did change. That's pretty cool. So that tells you a little something about what's going on here. Maybe it's sensing that the pickle object changed and then it picks it up, but in any respect, it seems like it's reloading that model every time and running it. And that's just something kind of cool to know. Anyhow, glad that got resolved, because otherwise I would have had to have done some more editing on this video. Can you tell it's late? It's late here. It's about 10 p.m. I should be in bed. Anyhow, all right. So we got the result that we were expecting, right? So we were expecting 87%, and that goes back to our item here. So that's pretty cool. All right. So that's what we wanted to do. We wanted to test our endpoint. One more thing that I wanted to show you. So you can test it you can test it here with Postman, but you can also do it in a notebook as well. So if you go back to the repo or the directory, we should have another file here called API test. Now, what's cool about this is you can hit that API from here as well. So let's close that out. You're loading this library called request. You're initializing this object with the URL that you're gonna hit, and then you're just gonna pass the JSON here. So let's just do this. Is it control? Is it alt? It's alt. And then drop our JSON there. As you can tell, this is from the previous run. So, and then you'll run this function here, and you should print the expected prediction. So let's see if that happens. So cool. Awesome. Fraud and 87% probability. So that's cool. So you have two ways to test your API. I think that's pretty cool. All right. So I think that wraps it up for us. The next thing that you would do is you would try to serve this up, have this application running in a server so that it's not running on your local machine, and it get pinged via API 24 hours a day, 7 days a week. But I think that we'll leave that for another tutorial. But I hope you enjoyed this tutorial. If you stuck around this long, please give me a like, drop me a comment, subscribe. Tell me what you like about these videos. Tell me what I can do better, and just keep on hacking. Some of the stuff is kind of hard. It's I think you should also note that by the time I get to this, I've tried many different hacky things until getting to this point, and you'll oftentimes be banging your head on certain things that aren't working. You just have to hack through those things, fight through them, and just keep at it. All right, thanks guys. Talk to you soon. Bye bye.